Okay, hopefully you've had a chance to read through this laboratory, because that's what I'm going to try to do this laboratory. I'm actually going to be using two screens, one to go back to this laboratory and then give you a picture of what I'm doing in the laboratory, but also another screen on one of our desktops to show you what's happening with the vernier probeware, so you can see what the graph looks like as well. Because the goal here is to be able to show you everything about what is needed here. So I have already set up the experiment. I have made the saturated solution that is referred to here. I have also made the acid solution that is referred to here, and I have set up the vernier equipment, pH probe, and so forth. So let me show you what that looks like here. So what you see here is this is my beaker with my 15 milliliters of hydrochloric acid. Actually, it's not. The hydrochloric acid is in here. This has my 15 milliliters of the CaOH2, the calcium hydroxide. This is my pH probe. It is in the beaker taking the measurement of the pH of the OH. And so what you need to remember from your sophomore year is that OH means that we have a base in here. So when we see what the pH is of this starting solution, you're going to notice that it is a basic solution. Okay. In my burette, I have put the 0.05 molar hydrochloric acid, and that's what I'm going to be adding drop by drop to my solution here. Let's go ahead and take a look at the graph that we're going to be presenting here. And let me make sure I get it so that you can see all of it. Way too big. Hang on. Here we go. All right, so there is my screen right now, and as you can see, we have a starting titrant, the pH of the titrant, and so this is going to be at 0 milliliters added. So what the first thing says to do is, before adding any HCl titrant, and I'm right under the portion of the laboratory called conducting the titration, it says to click collect. So I am going to go ahead and click collect. There's collect, and it immediately asks me to, it is doing time. Let me stop this because I have not opened the right experiment yet. Instead, I need to make sure I have the right experiment up. So I need to go find, I do a file open and find the right experiment. So hang on, everybody. But I've finally got the correct laboratory up. As you can see, my starting pH is 12.41. I'm going to click the collect button, and by clicking the collect button, it is automatically going to ask me if I want to keep it, and I'm going to click keep, and this is at a volume of 0 milliliters of hydrochloric acid. So I'm going to click 0 and click OK. So that starts my my titration, and as I go along, I'm going to be clicking keep, and I'm going to be adding some solution. So I'm going to go ahead and add some hydrochloric acid, and what I'm doing right now is I am stirring up the hydrochloric acid, and I'm going to go ahead and click keep. I have added a total of 3.5 milliliters, so I click keep, and I'm going to type in 3.5 milliliters, and I'm going to click OK. And so that's how my data collection is going to proceed. So what I'd like to do at this time is take you back to what exactly I'm doing with my titration. And so here is my burette, and I have it full of acid, and I am adding the acid to my beaker here. And as I add it, I'm going to be swirling like this. So my next amount I'm going to add is going to be another 3.5. We have come to the end of our titration, and the reason I know that so at this point in time we've come to the end of our laboratory, and I can tell that we've come to the end of our we've come to the end of our titration, and the reason I know is because we have a significant portion of the graph showing a very drastic decrease in the pH of our solution as we've added this volume. This is going to help us be able to solve for the unknown molarity of the CaOH2. So to make this solution, we actually are dissolving the solid calcium hydroxide into some water to make some ions, calcium 2 plus ions and OH 1 minus ions. And we have a 1:2 ratio going on there. And we can write out our Ksp equation as you see there on your screen. But in the titration, the reaction that we have happening is some hydrochloric acid reacting with some calcium hydroxide. And it's these hydroxide ions that we need to figure out the concentration of. So once we figure out the concentration of the hydroxide ions, we can plug it into here. Now, there's a lot going on here, and what I want you to be able to recognize is that in this equilibrium right here, and I'm rewriting it so we can see it down here. Remember, this is a solid. And we have the calcium 2 plus and the 2 OH 1 minus. We have that going on. So in our rice table, we have the initial concentration that is not in, none of this is going to matter for the solid, but our initial concentration of our calcium and our hydroxide was 0, and our change in concentration was going to be plus X, and the relationship of this one to this one is double, so 2X. So our equilibrium concentration of calcium ions is going to be 1/2 of the equilibrium concentration of hydroxide ions. So ultimately, if we can figure out what the OH concentration is, then we know what 2X is. So that means that we also know that the calcium concentration is equal to whatever the OH concentration is divided by 2. All right, so we have a lot of things that we get to figure out here. So the question becomes, well, how the heck are we going to determine the concentration of the hydroxide ion? Well, here is where some information about titrations would be very, very helpful to us. So what you need to know is that this graph is really, really helpful. In fact, on this graph, if we can determine what this volume is right here on our graph. Let me see if I can write on it. If we can determine what this volume is right here on our graph, then we know the volume of the HCl, and we already know the molarity of the HCl that is given to us in the laboratory, and we know that we have the volume of the CaOH solution that we already have. And so let me share this with you. If we know that it is a in our balanced equation, HCl plus CaOH2 yields H2O plus CaCl2, we know that we have a a 2-to-1 ratio. That means that we are going to be able to figure out what this concentration is if we can figure out what's missing. And so we have a relationship as in moles of the acid. 2 moles of the acid is twice, no, I'm sorry, let me get that back. Okay, the moles of the acid is equal to 1/2, or the moles of the base is 1/2 of the moles of the acid. And we have a relationship of molarity where we can do molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. And of course, that has to be divided by 2 because of our mole ratio. So there we go. We have our chemical reaction there, and that's helping us be able to tell the relationship. And of course, we know all of these values except for the molarity of the base, which is exactly what we have to figure out. All right? So to solve for the missing molarity of the base, we will end up with 2 times the molarity of the acid times the volume of the acid, of course, in liters, divided by the volume of the base also in liters. And that will give us the molarity of the base. And that's the missing molarity. It is the concentration of the hydroxide ion that we need to be able to solve this whole thing. Now, is there something else going on that might give us a better view of it? Because right now I would have to estimate somewhere between 20 and 30, and that's coming out by my eyeballing it somewhere around 24 milliliters. Is there a better way of doing this? And the answer is yes, there is a better way of doing this. Let's take a look at the vernier probe, where it actually does a really cool graph for us. And let me change the perspective here. All right. Let's stop this so we can actually, there we go. That is called a second derivative graph. And it turns out that right where the second derivative line crosses the zero line, right there is exactly where we have the equivalence point for us to be able to tell the volume of the HCl that we used. And so if I go put my cursor on that right there, I find that that is actually at, that volume of HCl is exactly at 23.88 milliliters of HCl. And so let's talk about this calculation a little bit. So our calculation was going to be the molarity of the base is equal to 2 times the molarity of the acid times the volume of the acid divided by the volume of the base. Okay, so here we go. 2 times the molarity of the acid, 0.05, times the volume of the acid, which we just said was 23.88 milliliters. And we're going to divide it by the volume of the base, and the volume of the base I used was 15 milliliters, so 0.015. So we should be able to solve using especially that second derivative graph to be able to help us solve there. And that is quite a lot going on.